When millions of people use Claude at the same time, what stops Claude from crashing? How does it answer millions of users' requests? And when you're running your own AI apps that are expensive to build, how can you reduce the cost without reducing the quality? That's where Kubernetes come in. Let me explain the concept to you. Imagine you have your own AI chatbot, and Monday morning, 50 people are using it. But then the next morning, a blog goes viral about your app, and now 10,000 people are hitting your app. But then the next day, it's back to 100 to 200 users. How can you handle that? Well, option A is you rent GPUs that are able to handle 10,000 users at a time. But then you're paying for 10,000 users worth of compute on Wednesday when only 200 people are online. And that's just unnecessary because you're paying like 20 times the cost. So option B is the Kubernetes. It watches the traffic of the users in real time and makes decisions automatically. It decides to auto scale. If there's a lot of people, they spin up more GPUs. But if there's less people, it'll use less GPUs and you only pay for what you're actually using. And there's also a concept called load balancing. So let's say 10,000 requests come in and the Kubernetes distributes them evenly across the servers so that not one GPU is getting overwhelmed and the other ones sit idle. It's that they're evenly distributed, so you're utilizing it. Kubernetes also offers self-healing, so if a server crashes, it automatically restarts and brings it back up. There's also model serving. Kubernetes orchestrates inference servers that we talked about in the last video, like VLLM, Triton, TGI, and manage which models run on which GPUs, so they can route requests to the right model. Every major AI product runs on Kubernetes, like Claude, ChatGPT, and Gemini. And when you use any of these chatbots, it responds in 2 seconds despite so many concurrent users existing because of Kubernetes controlling the traffic and making it happen. You don't need to learn how to build Kubernetes today. That's a really advanced topic. But you need to know they exist because they help move your AI apps from prototypes to actual apps that people would use. Now I'm going to talk a little bit about optimization, which I know is in week 5, but it's relevant to our discussion of Kubernetes right now. So Kubernetes keep your AI running, but running AI at a huge scale is pretty expensive. GPU compute is probably the biggest cost that AI companies suffer. So here's how you can smartly cut that bill dramatically. Technique 1 is model routing. The insight is simple. Not every question needs the most powerful model all the time. Because if someone asks what the capital of France is, or if they ask something simple like that, you don't need to use a huge model like Claude Opus. Maybe you'd use a smaller model like Claude Haiku instead, because it'll answer this question with similar quality for a fraction of the cost. But if someone needs to analyze some huge documents, that's when you would use the bigger and expensive model. Model routing means that you put a kind of classifier in front of the AI. So every incoming request gets classified as simple or complex, or maybe they get scored to see how complex they are. And simple questions would go to this fast, cheap model, and complex ones would go to the powerful, expensive one. And then in the real world, when the users are using it, a lot of the queries would go to the cheaper model, when only 20 to 30% would go to the most expensive one. And it would be the same user experience, but at a lot lower costs. There's also another one called KV cache management. So when you're talking to AI, the model stores the context of your conversation in the GPU memory, which is the KV cache. But long conversations, they eat up a lot of memory. And if you don't manage it, there's a lot of long conversations that can hog up the GPU memory, while a bunch of hundreds of short requests are waiting in line. So smart cache management would remove the old conversations and prioritize the active ones. And then once the person goes back into their long conversation, then the KV cache would go back to their conversation. But while it's not active, you'd prioritize the active ones. Third technique is auto-scaling. And we cover this with Kubernetes. But if your traffic is predictable, which is low at night, and high during business hours, auto-scaling just means that you're running 2 GPUs when it's the middle of the night instead of 20. But then at your busiest hours, you wouldn't still want 2 GPUs, you'd want the 20. And cloud hyperscalers bill by the hour, so that's a lot of cost reduction if it scales based on how many users you have. Technique 4 is spot instances. A lot of hyperscalers sell unused GPUs at huge discounts that are sometimes 60 to 70% off. But the catch is that they can reclaim the machine with a short notice, so they can revoke your access really quickly. So if you're using it for prototyping or batch jobs or processing requests that aren't time sensitive, then you could use spot instances. But if you're relying on users to use your app, then it wouldn't be the best way, because these spot instances can be shut down pretty quickly, but they're a lot cheaper to use. And you get the same hardware for just a fraction of the price. But it's not sustainable for real world apps. So if you use these 4 techniques, then you could get an AI app that cuts your infrastructure bill by a lot. So here's a recap. The Kubernetes handle the scaling, the load balancing, self-healing, and things like that. So AI stays up when traffic spikes, and it's able to scale down when there's not as many people. Model routing can send cheap questions to cheap models and big expensive questions to big expensive models. Autoscaling and spot instances can make sure you're never paying for GPUs that you don't need and you're not using. This wraps up week 4, and now you understand infrastructure and how important it is, and how it's the basis of AI apps. Now, week 5 is a little optional deep dive, but I would definitely recommend, where we go into optimizing AI. And this lesson over here was a sneak peek of optimizing AI, because I just discussed the ways that you can optimize Kubernetes to get your AI apps less cost. And the goal of optimizing AI is to lower these costs. So we'll go over fine-tuning, quantization, which makes models smaller and faster.